Hey guys, so bummed I can't be with you here on your last day in person, but I will see you remote on Monday. Remember to log in during your regular class period on Monday. But today we're going to be doing a lot of math, so buckle in. It's a big math day. Put on your algebra hat, do what you got to do, get out your calculator, get out your pencil, and let's get going. So I structured this video for you that this should take you the whole period, and there's spots for you to stop and pause and do your work, and then you'll come back and check in with me. So let's start. We are on page 15 in our Unit 3 packet. And again, whenever you need to, stop and pause and restart. And there's going to be some places where I tell you to stop and pause. So make sure you do what I say so that we get the most out of this. Okay, so we are on page 15. We're working on quantifying changes in energy when we have a phase change. So that's that plateau part of the graph. We're going to be using the equation Q equals mH. So remember, the old equation we used was MC delta T, but during a phase change, a plateau, remember, there is no delta T. The temperature doesn't change. So that equation's not going to work for us because it would mean Q would be equal to 0, and we know that's not true. Q isn't equal to 0 during a phase change. It takes energy. So we need a new equation. And if you remember from your lab, we learned that H is called heat of fusion right here, or heat of vaporization. We will use the label H little f for heat of fusion and H little v for heat of vaporization. If you want to write that down, that's just to keep the two straight so we don't get confused. One more thing we want to write down is when we have melting or evaporating, those two things are endothermic, so your H sub f is going to be positive. But freezing and condensing are exothermic. You have to take energy out, so those two numbers are going to be negative. So you have to be smarter than your calculator here. You have to make the decision on whether it's positive or negative. When you were doing Q equals MC delta T, it just worked out as long as you did your delta T right. But with Q equals MH, you have to decide whether it's positive or negative. So just make sure you pay attention to which phase change is happening. Other than that, this should be pretty easy math. It's definitely easier than what you did before with the Q equals MC delta T, because there's only 3 variables. So it's always nice when you have a 3 variable equation rather than the 4 variable one. So it says, suppose during volleyball practice you lost 1 kilogram of water. Now when I see kilogram, I'm going to automatically change that to grams. Remember, anytime you see that prefix kilo, whether it's kilograms, kilojoules, kilometer, if you multiply by 1,000, that takes it back to the base unit, because it's 1,000 base units in a kilo. So 1,000 grams in a kilogram. If all this water is evaporated, okay, so I see that phase change word there, evaporated, I look up here and I see, okay, evaporating, positive, that's going to be my H sub V, 2260. Okay, so I'm going to write down here, I'm using positive H sub V. That way I've got that ready to plug into my equation. How much energy did the water absorb from your body? Express your answer in kilojoules. Okay, so I'm calculating energy, Q. So Q equals my mass. So 1,000 grams times, I said H sub V positive, so times 2260 joules for every gram. So if you remember, I'm using the equation Q equals M times H, in this case, sub V. All right, I stick that in my calculator. Get this real big number. 2,260,000 joules. That's a lot. That's why the answer asks for in kilojoules, because it's a big number. So when we put it in kilojoules, we make it a little more manageable. So that'd be 2,260 kilojoules. And of course, we're going to round that to sig figs because we love sig figs. The only thing we've got to go off of here is this 1.0 kilograms. So I'm going to round it to 2 sig figs, which would be 2,300 kilojoules. And that's it. So once you got that, I want you to do a pause in a second, and you're going to do number 2. Now, the thing I want you to keep in mind for number 2 is that it's freezing. So again, be smarter than your calculator and make sure that you keep track of the positives and negatives where needed. So go ahead and do number 2, hit pause, come back when you're done. Okay, so we're back. Take a second to check your answer. Did you get it? So a couple things to note. This time around, the substance is freezing. So that means not only are we using H sub F, heat of fusion, but it's also going to be negative because it's exothermic heat's being taken out. So it's a negative H sub F. Same equation, Q equals mH. But now we're going to plug in our 340 grams of mass times our negative 334 joules for every gram. I rounded my answer to 3 sig figs right away, 114,000 joules. So again, hopefully these ones feel a little easier than the Q equals MC delta T, only the 3 variables to worry about. The hardest part is just deciding which H do I use and what sign do I make it. Okay, so we are going to move on to number 3 here. Now I'm going to let you do it on your own, but I want to give you a couple tips first. Okay, first thing. Suppose in the icy hot lava burner transfers 325 kilojoules. You know when I see that kilo, the first thing I do is I change that to regular joules and multiply it by 1,000, change that to joules because that's what we need. And then I also want to remind myself, joules, that's Q. So this question gave us Q. That's a little different. Before we were calculating Q, now we're given Q. It says the sample liquids at 100 degrees Celsius. I don't care about the temperature. I know water boils at 100 degrees Celsius. That's great. Thanks for telling me. But it doesn't matter for my math because I know there's no temperature change. So helpful information, maybe not needed. What mass of the water will be boiled away? So we're looking for mass, and it says boiled away. So that's going to be H sub V positive. These are the steps I go through when I go to solve a problem that's going to help you. So I know Q, I know H sub V, I need to solve for M. So remember, this is your equation. Q equals M times H sub V. I know Q, I know H sub V. This time I'm solving for M. So a little bit of algebra for you. So again, hit pause and come back when you got it. Okay, take a look. Did you get it? Did you get your equation set up right? Did you do your algebra right? Did you round your sig figs? We get 3 sig figs on this one because 325 kilojoules has 3 sig figs. So not too much harder, solving for mass, a little bit of algebra. So I want you to go do questions 4 and 5. These are the same thing. We're solving for mass. Just make sure you read the questions carefully. So do 4 and 5, and then come on back when you've got those done to check your answers. Okay, we're back. Do a quick little answer check there. I did not give you my full algebra workout. I just gave you my equations that I used in the answer. So make sure your equation is set up right. If your equation is set up right and you don't have the same answer as me, that is probably an algebra issue. So go back and make sure that you are dividing, not adding or subtracting, because mass times H sub V means we have to divide out that 2260. Notice here how it's negative 1500 and negative 2260. That's the trick with that one, is it says that energy was removed. So that means negative, and this is condensing, so that's negative. Because we can't end up with a negative mass, that wouldn't make sense. So that's how we deal with that. This one, the little trick or the difference was it gave you the heat of vaporization. So this is not water. This is ethyl alcohol. So those heats of vaporization and fusion on the front of the page only work with water. So when you have ethyl alcohol, they have to give you a new number. And so they actually gave you H sub V there. And so you need to make sure you use that instead of 2260 because it's not water. So let's take a look at 6 and 7. These ones are using the same skills, but because of their wording, it just might make them a little more confusing. So I want you to know on 6, it says if 2/3 of the ice was melted. So you have 450 grams of ice, but only 2/3 of it is melted. So see if you can figure out what to do with that 2/3. And the second one, we transfer all this energy into 2.5 kilograms of water, but it asks what fraction would be vaporized. So that's implying that this whole thing won't be vaporized. So this is actually just a simple solve for mass. So you're going to compare the mass you get to that 2.5 kilograms because it's saying 550,000 joules, not enough to vaporize 2,500 grams of water. So you're going to figure out how much it actually can vaporize. So you can check your answers to 6 and 7 on the key that is in your folder. If you don't get those done by the end of the first period working, that's totally okay. Those are just bonus. So you need to make sure that you have 1 through 5 done. 6 and 7 are bonus. If you have time in the period to work on 6 and 7, fantastic, go for it. If you don't have time, that is totally fine. You know what you're doing. If you got 1 through 5, you're good to go. Okay, so that is Q equals MH. Next period, we're going to be working on combining Q equals MC delta T with Q equals MH. So these are going to be multi-step problems that we combine together. So we'll see you then.